Good morning everyone. Today we are going to see a reflection by a glass slab. Generally slab is made up of a glass, so it is one of a transparent medium. So when the light rays passes from it, two times reflection occurs in it, right? So our topic is reflection by glass slab. One activity according to this is given to you in your book. It is 10.11 or 10.13, something this type of activity is there, right? So the reflection of a glass slab, you have to open your book and the activity 10.10 or 10.11 is there, right? So at here first of all you have to take a one glass slab. So here it is glass slab and you have to put that glass slab on the white drawing paper, right? First of all take a glass slab and just put it on a white drawing paper. Then you have to draw that glass slab, right? By drawing the edges of it. With the help of pencil you can draw edge of it by putting a glass slab on white drawing paper. So you get a glass slab like that, one rectangle. So here it is, glass slab. I am giving a name to it, P, Q, R, S. This glass slab has a two edges which has a name PQ and RS. This edge is a PQ and this edge is a RS. Why I am taking two edges at here? Because when the light is passing from air to the glass, during that time it incident on PQ, which is the interference between the two medium, right? Like that, when it just passes from this glass to the air, during the time the RS becomes the interference between the two medium. So at here, when I incident a one ray on it, like that. So here it is, ray of light, which is incident. So it is known as incident ray. Right? If I give a name as A, B, then this ray is incident on PQ surface at point B. As you know that when the incident array, you have to draw a normal to that surface for finding a angle of incidence, right? So here it is normal to the PQ at point B, at point B, which is the incidence point. So here it is normal, right? So it's a normal and the ray is incident at A. So the incidence angle, which is the angle between incident ray and the normal, is known as angle of incidence. At here I am taking angle of incidence as a theta 1. As a theta 1. Now, it's a air. Reflecting index of the air is 1. So here it is air. And here it is glass, which has N. As you know that the air is more thinner than the glass, right? So air is thin and the glass is thick medium, right? Optically thick medium. It is optically thin medium, here it is optically thick medium. So generally, when the ray passes from air to the glass, during that time is just move towards the normal. As I said you in a previous video, right? When the ray passes from a thin medium to the thick medium, optically rarer medium to the optically denser medium, during that time it just move towards the normal. When it is moving from rarer to the denser. As you know that air is more thin than the glass, so it is optically rarer medium and here it is optically denser medium. I am not talking about the thin according to a mass, optical density. The optical density of air is less, so it's a rare, and the optical density of glass is more, so it's a denser medium. So it's a rarer medium, it's a denser medium. So when these rays coming from rarer to the denser, it just move towards the normal. So it should be moved in this direction. So it reflects light. It is known as refracted ray. It is known as refracted. When it comes to the RS, at here this reflected ray is incident on RS on point C. If the reflected ray taken as a DC. Here is the reflection angle. If I am taking it at theta 2. It's a theta 2, it's a theta 1. Okay? Here is angle. This is the name theta. It's a theta. Okay, this angle is theta. And this ray is reflected. This ray is reflected, which incident on point C. Okay, as you know that when light incident on surface, you have to draw a normal to that surface. So here it is the normal. Okay. Now, after coming from the glass to the air, here it is also air, whose refractive index is 1. So when it passes from glass to the air, from denser to the air, it goes away from the normal, right? It just goes away from the normal. It should be like that. It just goes away like that. It is known as immersion. If I am taking here CD, so CD is the immersion, and this angle is theta 4. Why? This angle is theta 2. This angle is theta 3. Here this angle theta 4. Now, just think about it. If the glass slab is not here, then the reflection will not occur. Then ray just move on this path, a straight path, without refraction. Without refraction, it just goes on this path. You can see that these two rays are parallel to each other, and it is just displaced by some distance. Both are in the same direction but displaced by some distance. This displacement is known as lateral shift. It is known as lateral shift. So, just see it again. Okay? Here it is one glass slab, right? It is made up of glass, and outside of that there is air, right? So when the ray of light just passes from the air to the glass, during that time it just passes from rarer to the denser medium. When coming towards the denser medium, it just move towards the normal. So these rays reflect towards the normal and it makes a less angle than the incident angle. Then these rays just incident on the other side of the glass slab, right? So it again reflects because it passes from one transparent medium to the another. In this time, at here, it just passes from denser to the rarer medium. So it just moves away from the normal. Here it just come towards the normal and it just go away from the normal. But this emergent ray is exactly parallel to the ray of incidence. If glass slab is not there, then this ray will just go like that on this direction. Both are parallel. So you can say that both are in a single direction. If the two bikers are just moving in parallel, so they are going in a same direction. So like that they are in a same direction. But this emergent ray is just displaced by some distance. And this displacement is known as lateral shift. So like that, you can see a refraction by a glass slab. But how you have to write it? It's a one type of activity. So you have to write like a activity. So first of all, what you have to do? First of all, you have to write like that. Take a one white paper. Take a one white paper. Put a glass slab on it and draw edges of it. So you can draw an edge like that. Give a name P, Q, R and S. Okay? Now आफ्टर में आपको क्या लिखना है? इसके बाद आपको ये लिखना है कि ना अब उसकी जो PQ सरफेस है उस पे एक किरण यानी कि एक रे को उसके ऊपर इंसिडेंट करनी, राइट? सो यहाँ पे आपको क्या करना है? फर्स्ट ऑफ ऑल यू हैव टू टेक वन white paper, then you have to put one glass slab on it and then draw edges of it. Then you have to give a name P, Q and RS, in which the PQ is one surface, right? And the RS is one another surface. They are two parallel surfaces, right? Both their surfaces are parallel to each other, which makes an interference between the two different transparent medium, air and the glass and the air. At here is the air, medium is air. Here it is glass and here it is air, right? If air is N1, then it's N1 equals to 1. It's N2 and here it is, if it is N3, then the N3 is equal to 1, right? Because the refractive index of air is always same. So if it is 1, then here it is also 1. Now, you have to incident a one ray. So, draw an incident ray. Draw incident ray AB, which incident on surface PQ at point B, with making an angle of incidence as a theta 1. So you have to incident a one ray. Incidence. The ray is AB, which is incident on surface PQ at point B, by making angle of incidence theta 1. So here it is normal. And this makes an angle theta. So you just incident a one ray. Now you have to put two pins on incident ray. So put a pin P1 and P2 on incident ray. So you put two pins P1 and P2 on incident ray. Now put a slab on the edges of their glass slab, right? Then just see from the other side. you have to see that two pins from the other side, and just put two other pins which are exactly on the same line of P1 and P2. If one pin is like that, then the second one should be like that. You have to put a third one which gives you a same vision, just on the same line. Then the fourth one should be exactly on the same line. So you get two different pins on the other side. So you have to put a two pin. These two pins are just put on the incident ray. Then you have to see from the other side of the glass there. And you can see the image of P1 and P2. There you have to put two different pins in P3. You have to put P3. Like that, the P1, P2 and P3 comes in a same line. Then you have to put another pin P4, which should be also on the same line. Which should be also on the same line. Now you have to connect both the pins. And just extend it towards the side arrows. Give a name. It's a C and here it is D. It is also one of the way, which is the immersion way. Which is the immersion. Now, for finding the immersion angle, you have to draw normal, and you get angle of immersion, right? So here it is our half process of it. First of all, take a white drawing paper, put a slab on it, then draw edges of it, given a P, Q, R and S. Now draw a one ray AB, which should be incident on B by making an angle of incidence as a theta 1. Now put two pins on the incident ray. Now put a glass slab and see from the other side. And put a pin P3 such that P1, P2 and P3 comes in a one line. Then put a P4 such that P1, P2, P3 and P4 all ions can be seen in same line. Then connect a P3 and P4 and just extend it towards the side arrows. When it just touches to the arrows, you have to give a name C and D. Then it becomes an immersion ray C. Then you have to connect B and C. Now connect point B and point C and give a name of angle theta 2, theta 3. Now you can see it here. Here it is the refraction by glass. When it comes from air to the glass, it just goes towards the normal. And when it just goes from the glass to the air, it just moves away from the normal. So rarer to the denser, towards the normal, and denser to the rarer, away from the normal. So like that, with the help of activity, you can easily understand the refraction by a glass slab, in which by the two parallel sides, the 2 times refraction is occurs. Right? When rarer to the denser, towards the normal, and denser to the rarer, away from the normal. Most important thing is that if there is no glass slab, then here it is the direction of ray. Here it is direction of ray, on which the ray can be moved in this direction. But due to slab, the refraction is occurs, and you get an immersion ray which is slightly displaced by its original path. Here it is the displacement. And this displacement is known as lateral shift. This displacement is known as lateral shift, in which you can easily see two rays which are parallel to each other. They are going in the same direction but displaced by some distance, which is known as lateral shift. So here it is, refraction by a glass slab. The definition of lateral shift is that when the ray is refracted by two parallel refracting surface, emergent ray go in the direction of incident ray, but slightly displaced by it. This displacement is known as lateral shift. When a ray of light incident on one surface and refracted by two parallel refracted surfaces, the emergent ray move in the direction of incident ray but slightly displaced by it. This displacement is known as lateral shift. So here it is the topic, refraction by glass slab. You have to write this activity from your book, 10.10 or 10.11, something like that. Okay, activity number 10.10, I think. Right? So you have to write this activity and you have to draw this figure. Thank you.